Previously on Forever Chemicals.
We explored alternative chemistries and other environmental issues we face within the outdoor industry.
If I start with what is PFAS? PFAS is a very big group of fluoroorganic chemicals and polymers. They have what we call extraordinary properties.
PFAS are industrial chemicals, and the carbon-fluorine bond is perhaps the strongest in the periodic table. It takes the energy of lightning to break it.
PFAS are known as forever chemicals.
The chemical industry knew that PFAS could be harmful.
So it's used in places that folks don't think. It's in every pizza box that you've gotten a pizza in. It's in your coffee cup at your favorite coffee joint around the corner. It's in cosmetics. It's everywhere.
PFAS chemicals are wreaking havoc on our health and environment.
It's a really serious issue.
So there's health impacts and there are environmental impacts.
So many of them have been found to last essentially on geologic time.
Difficult to remove, difficult to filter, and then once removed and filtered, difficult to dispose of. They have been found to bioaccumulate in people and animals and have been found in almost every living creature on Earth.
We need to eliminate our apparent appetite for using PFAS.
The environmental impacts are pretty potent. Many of us refer to these as forever chemicals.
In order to destroy it, it takes extreme conditions. There are technologies that can destroy PFAS, but it takes extreme temperature and extreme pressure to do so. Common combustion, common biological degradation does not degrade the compounds.
Throughout this 10-part series, scientists, lawyers, advocates, and product producers all weighed in on our worldwide PFAS problem. While yes, we have come a long way in understanding the scope of the issue and began moving away from PFAS, at least in the outdoor industry, many questions still remain.
I think that we need, of course, some agreement on how to proceed in regard to the past exposures, because we are all exposed to PFAS, in part from our current consumption, consumer products, etc., contaminated food, contaminated drinking water. But some of that PFAS is old. It is something that was produced and disseminated decades ago.
One of the primary questions is, what do we do with all of the old PFAS that is already in the environment?
My name is Matthew Eshed. I'm a mechanical and systems engineer. I've been working on new product development and specifically focused on sustainability and innovation for about 10 years. When we think about destroying the chemicals, all of those technologies are classified by the ITRC as limited application and developing. That means that it has been used and proven on a relatively small scale. A limited application would be in 1 or 2 facilities with maybe less than 10 or less than a dozen peer-reviewed studies on how well it's worked. And then developing would be even less use. All of those technologies for destroying the molecules is in that limited application and developing area of things. As far as the field implemented treatment technologies, there's ways to filter, and there's basically putting it in a hole, putting it in a landfill, gathering it, and then now you have it concentrated form. So put it in a hole, and then later we'll do something about it. So there's this big rush, big interest among people and companies in this space, among the Department of Defense and the federal government and water utilities. There's a lot of interest in how to destroy them quickly. So that space is pretty hot right now. Where is it? And then how do we capture it? And how do we destroy it?
Well, let's focus on groundwater. So let's say you have a plume of PFAS emanating from a site, and it's moving down gradient towards a receptor. The common approach, or I should say the knee-jerk reaction approach, is to put in a well and to pump that well to recover the plume, and to think that you're going to rinse the aquifer clean of PFAS. That is not going to happen. The aquifer is not going to be rinsed clean by pumping water out. It will not flush out in lifetimes and lifetimes of pumping. Just as an aside, there's another type of contaminant that has shown up in groundwater since the 80s called chlorinated solvents, and these are like dry cleaning solvents and that sort of thing. We've been trying to clean dry cleaning solvents out of the groundwater for 40 years with pumping and flushing aquifers, and it hasn't worked. And after 40 years of wasting our time pumping, we haven't gotten rid of it. Well, it turns out that PFAS has compounds that are like 10 times as sorptive to aquifer materials as these chlorinated solvents that we haven't been able to treat 40 years. So what's that, 400 years of pumping it's going to take? And the cleanup goals that are established due to the toxicity and the bioaccumulation of PFAS, the cleanup goals are 3 orders of magnitude lower than these chlorinated solvents that we've been trying to clean up with pumping for 40 years. So I don't know, pick a number, 1,000 years of pumping, I don't know. But it's not going to work. You cannot flush PFAS out of an aquifer with pumping. So putting in a recovery well to try to capture the head of the plume is one way to contain the PFAS plume. But when you do that, you now draw water to the surface with PFAS, very small amounts of PFAS. So you have to then separate the PFAS out above ground. So you have to take all this energy from pumping to get it to the surface. Then you have to treat it to separate it out through using things like granular activated carbon canisters that then have to be taken off to a disposal facility or incinerated. Or you can bubble air through the recovered water and try to collect the foam of the PFAS foam. Then you have to put that into barrels and send them on trains to a disposal facility or destroy it. So this is a very expensive endeavor that doesn't flush the aquifer clean. It still is a contaminated aquifer. So let me tell you about what Regenesis has done. What we've done is we've taken the approach of saying, instead of pumping the water to the surface and having to separate it out onto this activated carbon or onto other filters or bubbling it off and then taking it off to a disposal facility, what we've done is we've taken charcoal, highly effective filtration charcoal. Instead of pulling the water out of the ground and putting it through that, we've milled this charcoal down to the size of a red blood cell, less than 2 microns. And we've wrapped all these little particles with polymers that are negatively charged so that they bounce off each other. And they're so small that they don't drop out of suspension. It looks like black ink. We take that, we call it plume stop. We take this plume stop, this very, very small particles of carbon and water, and we pour it down into the polluted aquifer, right into the head of this plume of PFAS, into the ground. And what it does is it moves out into the aquifer and it coats the entire aquifer surface, that's impacted aquifer surface. So all those little pores are now filled with this plume stop, and anywhere there's a positive charge in the subsurface, these negative charges stick and the particles stay permanently attached to the aquifer materials, whether it's cracks in rock or whether it's the spaces between sand grains. So this entire aquifer becomes a huge purifying filter. Those particles of our plume stop are permanently adhering to that aquifer. So any water that's contaminated with PFAS moves through this area, the PFAS is stripped out of the water and onto the particles. And the longevity, how much time do you have with an injection? Well, if you put this plume stop into the ground, you convert that aquifer into a purifying filter for decades at a time. And so you can put an injection of plume stop in the ground and convert that aquifer into a purifying filter for 50 years with one injection. And if you go up gradient, back up to the source, the fire training pit, and treat that too, you may not ever have to come back. If you do have to come back, you just simply inject another injection of plume stop and you get another 50 years of longevity of filtration. So what we've done is we've eliminated the risk to people down gradient from the PFAS by locking it in the aquifer forever, where it's not going to be able to expose anyone down gradient, any water bodies down gradient, or any aerosol or any air release to the atmosphere. So that's what we've done. And that solution it's been accomplished now in 50 sites around the world, ranging from major airports to major petroleum refineries. It's being performed for about 1/3 the cost of any other approach. No waste generated. It eliminates the risk to anyone down gradient. So PFOS and PFOA are the most notorious because they were very prevalent in some of the early foams and some of the early products. They're also among the longest chain and therefore the most bioaccumulative. And so they have among the most low cleanup standards. So we think once the EPA finally makes up their mind and promulgates these regulations, we feel that those two compounds will have very, very, very low cleanup criteria. Because they're so widespread, they were used so widely, and because of their bioaccumulative nature and the low cleanup standards, they will be the drivers on most all of these cleanup sites. Now, there are smaller chain, shorter chain compounds that don't sorb as well to plume stop. So instead of having, let's say, 50 to 70 years of longevity, a plume stop treatment towards those might only be 20 or 30 years. However, they generally have much higher cleanup goals because they're not as bioaccumulative. And so, in terms of meeting cleanup criteria, we feel the plume stop will meet cleanup criteria for most all of those chemicals. Now, there are some very rarely found and unique PFAS-related chemicals that chemically have ether linkages and so forth that make them even more water-soluble and less sorptive. But they're rarely found, and we don't think that of those 50,000 some sites out there, you won't encounter those at any of the project sites.
Innovations are underway in addressing PFAS cleanups around the world, but with limited application and minimal oversight from governing bodies like the EPA. Many experts struggle to even explain the scope of the issue because the pollution is so widespread. But we can still look to some EPA standards to better understand how difficult it will be to achieve low enough limits within our drinking water, eliminate industrial use, and establish more effective cleanup standards. This year, the EPA established the first ever national legally enforceable drinking water standard for PFAS. In April 2024, the EPA finalized the National Primary Drinking Water Regulation for 6 types of PFAS, which protects about 100 million people from PFAS exposure. And before that, in January 2024, the EPA finalized a rule that prevents companies from starting or resuming the manufacture or processing of 329 different PFAS, released 3 methods to better measure PFAS in the environment, and announced the addition of 7 PFAS to the list of chemicals covered by the Toxics Release Inventory. The Toxics Release Inventory is a program by the EPA under the Emergency Planning and Community Right to Know Act, requiring industries to report annually on the release and transfer of select toxic chemicals. But perhaps the most important change relevant to cleaning up PFAS in the environment is that 2 types of PFAS, PFOA and PFOS, have been added to the Comprehensive Environmental Response, Compensation, and Liability Act, CERCLA, or better known as Superfund. Under this rule, entities are required to immediately report releases of PFOA and PFOS that meet or exceed the reportable quantity of 1 pound within a 24-hour period to the National Response Center, state, tribal, or local emergency responders. Some entities, though, including community water systems and publicly owned treatment works, municipal separate stormwater sewer systems, publicly owned and operated municipal solid waste landfills, publicly owned airports and local fire departments, and farms where biosolids are applied to the land, are all protected from being required to pay the bill for cleaning up PFAS from their sites. They will still have to be in compliance with the US EPA's enforceable discharge limits of PFOA and PFOS, but they're still exempt from paying for those cleanup efforts.
The US EPA has done some detailed work with all sorts of research universities and institutions, and they put preliminary drinking water goals out there, which means the cleanup goals. In other words, what is the limit that we can have within our water and still have a fairly low risk of being impacted with toxicity or carcinogenicity? They're looking at around 4 parts per trillion as a cleanup standard. It's extremely low. And again, why is it so low? It comes back to the bioaccumulation, right? If you drink the water from when you're a little child to an older person from the same house that's being impacted at a low level, you're drinking that water, even a small amount will impact you over time because of the bioaccumulation and the fact that there's no biological destruction, chemical destruction of this thing.
To me, hearing 4 parts per trillion was a hard number to wrap my head around. To break it down, a concentration of 1 part per trillion means that there's 1 part of a substance for every 1 trillion parts of either the air, water, or soil in which it is contained. The most recent EPA ruling on proposed levels of PFAS in drinking water only covers 6 types of PFAS. Only 2 types of those PFAS are limited to 4 parts per trillion, while 4 other ones, including Gen X, should not exceed 1 parts per trillion. 1 part per trillion is equivalent to a single drop of water in 20 Olympic-sized swimming pools.
To date, many people have become aware of PFAS, and it's a huge regulatory concern. So there's been a lot of sampling and analysis and assessing sites to see if there's PFAS present. There has been very, very little cleanup efforts to date. And the reason for that is everybody is holding their breath and waiting for the US EPA to come up with standards. Right now, there's no federal standard. There are some state standards, but federally regulated airports, federally regulated military bases, these big notorious sites, they don't have cleanup standards to meet because the US EPA has not promulgated any or come up with any decisions on exactly what they're going to need to have as cleanup standards. They proposed very low levels, but they haven't been finalized. So I think a lot of these sites are waiting to know what standards they have to reach, and then they'll move forward with cleanup activities. In the near future, the US EPA is claiming that they will regulate PFOA and PFOS as hazardous substances under the Superfund law. And when that happens, that will be a real call to action. So we think that once that occurs, many of the facilities that are handling PFOS and PFOA in the past, they will step up and have to do something about cleaning up the sites that they've impacted. Not a lot is happening on the cleanup side yet, but I think everybody's waiting for the EPA to make a decision. And once that happens, I think that there will be a lot of cleanups.
We may be waiting for federal guidance on some level, but many states are tackling this on their own. So what will future cleanups look like moving forward?
The pumping of the groundwater out and treating above ground, that's called ex situ. It's out of the earth. I think we're going to see less and less of those ex situ attempts to degrade pollution that's in the environment. It just leads to more risk and more exposure from aerosols going into the atmosphere, trucks overturning and waste spilling like we saw derailment in New Palestine, Ohio. I think we'll see less and less of that. Instead, what we'll see is we'll see the in-use, in-situ, in-place cleanup where compounds like our plume stop are injected into the ground and converting the entire aquifer to a purifying filter and keeping it down there so that there's no exposure or potential exposure to human health or the environment. I think that's what we're going to see. We'll see more in-place filtration and elimination of the risk rather than trying to bring it above ground and take it off to some incinerator that may in fact be generating partially degraded compounds into the atmosphere, etc. In terms of PFAS contamination, we have greater and greater capabilities to measure lower and lower within environmental samples. And that's just driving lower and lower cleanup concentrations for these emerging contaminants. I think that as we move forward and the regulations actually come out for cleanup, I think that we're going to find that there's more sites than we know of now that will need cleanup, and that people will be moving to treat it in place below the earth.
It's good to hear that cleanup efforts are underway in some areas. Or at the very least, organizations like Regenesis are innovating ways to help us limit our exposure to PFAS and other toxic chemicals. Regenesis isn't the only company working on the cleanup issue either. Other scientists and companies have been working on developing new technologies to find innovative ways to remove PFAS from the environment. A few of these innovations are discussed on the Woodward and Curran Disrupting PFAS podcast. Some examples of upcoming science surrounding PFAS cleanups mentioned on their podcast include phytoremediation, which means using plants to remove PFAS from soils, electrochemical oxidation, and the use of Acidomycobium bacterium A6 as a way to help PFAS degrade in the environment. Many of these concepts mentioned are still being studied and have limited application. I won't go into too much detail regarding the science behind some of these approaches, but I will link to that podcast in the show notes if you'd like to learn more about PFAS cleanups and remediation.
What these current remediation technology can do is that you remove between 30 and 50% of the pollution of PFAS in water currents. This is connected to the scaling up, and we're talking millions of cubic meters per hour that have to be cleaned up. And I think that's the scaling is a big problem. You have technologies where you can remove almost every molecule, reverse osmosis, but you cannot do that with big flows, high volumes. So the scaling here, if you have small, very small currents, very small volumes, you can really do it. And if you scale it up, that's quite expensive. If it's technically feasible at all, who will invest in this? Because that would cost a fortune to invest in one plant. I'm hopeful. I think at some point we will at least reduce the content of PFAS to acceptable hygiene levels, but we will never get rid of them to 100%. Not in economically feasible frames. That will not be possible.
Because we may never be 100% free of PFAS on Earth, the work within the outdoor industry does not stop in 2025, when many brands are aiming to meet the California AB 1817 regulatory standards. While textile regulations in states like New York and California are influencing massive changes in the industry, it is likely that outdoor products on Amazon and elsewhere will still contain PFAS and can be sold in the remaining 47 states that have no regulations surrounding the use of PFAS in textiles. Some outdoor brands are even trying to sell products containing PFAS with exemptions for, quote, severe wet weather products. Needless to say, we still have a lot to do to not only address the PFAS problem, but also to address sustainability in our industry as a whole.
The challenge is that the most important sustainability efforts are not sexy. They are very much foundational. And the first and most important one is know your network, know your supply network, because I guarantee you, you do not. Even those that tell me that they do, I can prove to them that they don't. And if this isn't a game, I've been doing this for some time now. And the challenge is that, yes, we may know our tier 1. Okay, but do I know all of my tier 2? And are you aware that up to 25% of your tier 2 is going to be doing their outsourcing? They're dying. And, could be 15 to 20% are outsourcing their coding processes or finished chemistries. So there's a lot going on in your network that you are not aware of. And if you're not aware of it, you're not aware of the integrity and the quality of these suppliers. So first and foremost is really spend the time, make it a priority that you really get to know your network. And then really spend the time to make sure your network is as good as it can be. And there's lots of ways that you can do that. Bluesign isn't the only, we help in many respects, but focus primarily on tier 2. So really, I think that's probably one of the most important things that organizations should be doing, brand organizations should be doing, because without that, it's so hard to do almost anything else. Because even calculating your carbon footprint, we as an industry, as most industries are, calculating our carbon footprints based on models, not on actual. We're not creating a true carbon footprint of our product and supply chain. And you can't do that. You can't even begin to do that. We talk about the need for primary data to know our carbon footprint. But if you don't even know your supply chain, if you had primary data, what good is it to you? And you cannot make a change. You can't improve upon your carbon footprint or your chemical footprint or your water footprint or any footprint if you don't know the actual numbers, because you can't just make the models better. And so there are issues like know your supply chain, really know your materials. I mean, things like that, which are the basic parts of when I assess a brand. I'm not asking about the most latest, greatest exotic materials and what you're doing about that. It's really the fundamentals.
Looking to the future as consumers and as an industry, it can be difficult to remain optimistic, knowing what we all know now, and knowing that our work is far from over. Luckily, there are countless scientists, advocates, companies, and lawmakers pushing for cleaner chemistry and a healthier world in collaboration with one another.
Bringing more research into the mix with 3M and Chemours, or DuPont's predecessor companies, putting so much investment into these chemicals over so many years. Now it's time for a new generation to proceed with that research, but perhaps based on a different foundation that's not just based on function, but also based on ecosystem effect, and that includes humans in the ecosystem.
90% of all the environmental impacts that any single product is going to have comes at the product level. So from raw material to actually making the product, once it leaves the factory and gets to the customer, pretty much all the environmental impact has kind of taken place. And so I really think focusing on that product creation aspect is key. And I think a lot of brands do a great job of doing that, but there is so much work to be done. And that kind of leads to the next thing, which I'm really excited about personally, is the innovation aspect. Since my career started, I guess in 2008, I've never seen any shakeup like this where every brand in the industry, I mean, across industries, have to make such a big change. And that really opens the door for a lot of really great new ideas and kind of a scramble to come up with what the new cool thing is. I'm really excited about that, as well as, the notion of circularity. A lot of talk around circulating products and materials kind of at their highest value is a really interesting idea. Some industries are ahead of others. I think the outdoor industry is maybe one of the leaders in that space. We have a lot of really great brands that are focused on excellent repair and warranty programs to resale programs to helping their customers find ways of like end of life solutions. So really like the idea of keeping products in use longer, circulating them to people who need them when maybe someone else doesn't. That to me is like really exciting. That's kind of what gets me fired up these days, I guess you could say.
The industry is only going to achieve this through collaboration. One of my favorite sayings of somebody in sustainability in the industry that I really love is what's our failure of teaching our children these days? And it's that there's only one winner and there's lots of losers. We don't teach our children how to collaborate with their competitors. And I think what the Outdoor Industry Association is now doing in response to this legislation is understanding and believing that we need to be talking about this together in terms of what worked for you. Again, very not competitively, not antitrust, all the right ways of doing it, sort of not specifically to names and prices and stuff we can't share, but just be open forum for, hey, how is this going? What are you learning? That is going to help us understand the problem better and find a solution together and have more unified conversations. I think this on the back of COVID, where the industry has not come together as much in the last couple of years, was really harmful in that there wasn't as many good connections to say, phone a friend, call my friend over at this other brand. Hey guys, I need some help. Can you introduce me to somebody that is good at such and such and so and so? Those are gold. On the flip side, I think we're finding lots of interesting discussions around educating the regulators and legislators about some of this legislation. It's not that the outdoor industry doesn't want to do cleaner materials and cleaner chemistry. In fact, we're an industry, I think, that's pretty clear about wanting to be sustainable and has a really invested interest in doing better and being green and helping reduce climate change and all the other good political buzzwords in there. But we have to do it within the constraints of our businesses. And 18-month lead time means if you put a law in place that takes effect next year, it's really challenging for us to work on that. So I think it's an opportunity for us to continue some of the work done on outdoor rec and recognizing the outdoor industries and recreation's contributions to states and commerce broadly, economy, the outdoor economy, and say, let us educate you on these things and work together to create ways to do better as a group so that it's easy for us to actually execute.
As it is such a big topic in general, we only can work all together. We have to work in communities, brands have to work together, suppliers have to work together, the chemical industry. There are a lot of projects going on where really all the stakeholders have constant meetings and discussions about, in any kind of directions, everything that is sustainability related. And I think nowadays, it is the only way that we really can, on a long term and on a effective way, change our industry. Other than that, it's not possible. It's not possible to find the own way. We only can do it together.
As leaders in the outdoor industry, it's important to understand that we have a role to play. We are an industry that tends to be more progressive on many of these issues. And so it's important to demonstrate that level of leadership. And just fundamentally, we need to understand that these chemicals are hazardous and we should be doing our part to purge them from supply chain. And again, happy that that is the case with many brands in the outdoor industry. And it's just, I think it's critically important for the overall kind of health and long-term future, not only of the planet, but of the industry itself.
The industry is and needs to continue to take responsibility for their use of harmful chemicals like PFAS. But as consumers, we can also make a difference and influence a positive change.
So as consumers, we have incredible power to make change. A few years ago, we were campaigning to get companies like McDonald's and Burger King to take action on PFAS. And when we reached out to them, they kind of ignored us. They blew us off. But then when we mobilized tens of thousands of consumers who signed petitions to McDonald's and Burger King, who visited their stores, organizing demonstrations and media events, investors engaged the companies. Both companies listened and committed to global phase outs of PFAS. So reach out to your favorite companies if you think that their products may contain PFAS. For example, if a product is marketed as stain or water resistant, or if it's used for a greasy food, or if it's, an outdoor jacket that says it's rainproof or water resistant, that's a pretty good signal that it may contain PFAS. So reach out to your favorite brands and retailers and ask them to take action on PFAS. If you go to our website at toxicfreefuture.org, you can find a lot of information about this problem. We actually have a petition on our website right now calling on Sally Beauty as one of the biggest beauty retailers in the country to take action and get dangerous chemicals like PFAS and formaldehyde out of the products that they sell. So that's an easy step that people can do. They go to our website, toxicfreefuture.org, click take action. You can send a message to the CEO of Sally Beauty right now and urge them to ban PFAS in their products. It's also important that U.S. residents flex our citizen muscle. So reach out to your elected officials at the state level and at the federal level and encourage them to enact policies to restrict PFAS. A really great resource that consumers can look at to understand what states have and haven't restricted PFAS is the website saferstates.org. And that has great information right now about what states have already enacted laws restricting PFAS. For example, there's about a dozen states that have banned PFAS in food packaging. And then it has information about what states have yet to enact policies banning PFAS. So write to your elected officials at the state level and the federal level and encourage them to enact legislation restricting PFAS in products, everything from food packaging to clothing, to electronics, to firefighting foam, which, by the way, is one of the biggest sources of PFAS in drinking water sources around the U.S.
If you want to learn more about what PFAS are, where they're found, the proven health effects, how you can limit your exposure, up-to-date news on PFAS, and how to get involved in PFAS regulatory efforts, visit toxicfreefuture.org, foodandwaterwatch.org, or pfascentral.org. SnapLink Consulting provided expert fact-checking and guidance for the creation of this podcast. SnapLink Consulting provides corporate sustainability strategies and ESG support across a broad range of industries, including apparel, footwear, home furnishings, software, cosmetics, professional services, and more. Head to snaplinkconsulting.com to learn more and contact the experts to guide you through complex topics like CSRD, PFAS, greenhouse gas assessments, SBTI, CDP, EcoVadis, B Corp, and many more compliance and certification frameworks. Forever Chemicals is a Black-Footed Ferret production. All the source material for this episode can be found in the show notes or at theoutdoorminimalist.com/Forever Chemicals. As an independent podcast, we rely on listener support as our primary avenue for funding. If you like this show and our other content, consider donating to our GoFundMe. The link is in the show notes. The Forever Chemicals podcast was written and produced by Meg Carney. Audio mixing and editing by Alex Carney and Ethan Weiss. Cover art designed by Savannah Cuthbertson. Special thank you to Logan Bankston, Jay Stewart, Ami Bornstein, Kate Ketschek, the Food and Water Watch, and Beatrice Gomberg for your guidance, consultation, investment, or insights while creating this series. The Forever Chemicals podcast was made possible by all of our featured interview guests. Thank you for sharing your time and expertise with all of us. Listed in order of their appearance: Arlene Bloom, Mike Shade, Stefan Posner, Scott Wilson, James Pollock, Philippe Grandjean, Ami Bornstein, Alex Laver, Kevin Mayette, Kyla Bennett, Natalie Balbuena, Ava Carlson, Brian Davidson, Chris Cody, Regina Galler, Donna Bruns, Martine Axelhead, Kirsten Blackburn, Greg Breitmaier, Teresa McKenney, Matthew Eshed, Robert Blatt, and Gabriella Whitaker.
Listen, y'all, I got something to say about a chemical that's causing dismay. It's called PFAS. It's a real threat to our health, the environment. We can't forget PFAS. We gotta condemn. This toxic chemical we can't let win. It's in our water, in our food, in our air. We gotta take action, gotta show we care. So let's come together, let's make a stand for our health and the health of the land. We gotta speak up, gotta make some noise to ban PFAS for our girls and boys.